they can do their own experiments. You know, what are they going to
Anytime they
test?
change color, you need sunblock. That's very interesting.
Yeah.
Because it's only that special UV from the sun that is changing that color.
And why are they changing to different colors?
Right. So each one of these, you can buy all blue or all yellow or all orange. I usually buy the multi-pack. So there are different chemical compounds in each one of them. So what really happens is that you have an atom, and the nucleus of the atom is where you have the protons and the neutrons. And that's pretty dense, and they don't, if the protons or neutrons come out of the nucleus, you have a nuclear explosion. So obviously that doesn't happen real often. Not on its own, anyway. So we don't really worry about the nuclei of the atoms, but the electrons are in clouds that completely envelop the nucleus. So there'd be like, so if you think of the nucleus as being like a mustard seed, which is the smallest known seed to mankind and makes the biggest tree, and you put it inside of a ping pong ball, some of the electrons will be kind of sitting on the ping pong ball. Take the ping pong ball, put it inside of a baseball. The next set of electrons will be sort of on the baseball. Take the baseball, put it inside of a basketball. The next electrons will be on the basketball. So those electrons can jump from one level to another. So all the electrons are close to the nucleus. They're all in their shells, we call them, or clouds. So what I'm giving you is the old model that is not complicated enough to explain modern chemistry, but it works for younger kids. Turns out that the electrons are not sitting on the shells, they're actually in a cloud. It's much more fluid, it's just that the clouds are concentric. When you add energy, some of the electrons that are close to the nucleus get the UV light and jump to a higher cloud. And once you turn off the UV light, they can't stay there, so they're going to start to fall down. They've used some of the energy you gave them to jump. When they fall back down, it doesn't have to be to where they came, it just has to be wherever there's an empty hole in a lower shell. They'll give you back whatever extra energy they have. If it's a little bit of energy, the light will be red. If it's a lot of energy, the light will be blue. Depends how much they used up and what shell they're falling back down to. But if you get that, that's pretty much what we'll tell high school kids. The real story is a little bit more complicated. The real story says that when you have two atoms that are bonded together, it's the electrons that form the bonds in these two clouds. When you shine UV light on it and some of the electrons jump, the bonds change. And when they change, the molecular shape changes. So now if you had like a smooth surface, now you might have a sharp surface, and it's reflecting light differently. So it's the molecular change, the shape of the molecule that's changing that reflects the different colors that you see here. So there are different molecules in each of the paints that they use, and one, when its electrons jump and change the bonds, it will form a shape that reflects light as blue. Another one will form a shape that reflects light as yellow. That's called molecular orbital theory. People win Nobel Prizes for that kind of explanation. So we don't do that till college. In the high school, we just explain to them that the electrons are coming down, giving you the extra energy. It's not accurate, but it's good enough for where they are. With the little kids, we just use it as a UV detector. But I tried to give you some of the background so that if a question came up, you knew what was coming. So UV rays of the sun provide energy to the atoms, actually the electrons of the atoms. The electrons jump to higher energy plane. They disrupt the bonds in the molecules of the paint, forcing a reconfiguration of the molecule to a different shape. Shape of the molecule affects how reflected energy is perceived color-wise. This gives you the nucleus with the electrons in these concentric clouds, jumping to, once it gets the UV light. So once the UV light is gone, it doesn't have the energy to do any kind of jumping. It's off the trapeze, and it's sitting still. The concept is that color is indicative of a particular energy. So if you follow this with that, there's some kind of connection. It's way too sophisticated for them, but at least there's some kind of connection.
That's a good combination.